Hello friends, I'm Professor Aditya Bhavne. Today we are going to learn impact of jet on inclined plate and hinge plate. At the end of this session, students or learner will learn the impact of jet on series of vanes, then understand the force exerted by jet on inclined moving plate, and then understand and calculate the force exerted by the jet on hinged plate. So in last lecture we studied the force impacting on the plate which are mounted on a wheel. Okay, and for this case, whenever jet strikes the plate, the second plate will come here and takes its place. So mass flow rate will remain same for this particular area. So in this case, lengthening of jet is not occurring. So whenever lengthening of jet is not occurring, the mass flow rate is given as rho a v. Getting? So mass flow rate is rho a v, and initial velocity with which jet and this will strike will be relative velocity, as both are moving, and we consider it as v minus u. So and final velocity when it strikes to the plate, the momentum will be destroyed and final velocity becomes 0, that is 0. So now force along x direction can be calculated as mass flow rate into initial velocity minus final velocity. It can be taken as rho a v, v minus u, final velocity 0. So Fx equal to rho a v in bracket v minus u. Now we have calculated Fx equal to rho a v, v minus u. Now if you calculate the efficiency, so efficiency is nothing but output by input. So output is work done, movement of shaft, and kinetic energy. So work done is calculated by force into displacement of that particular wheel, that is with the velocity u. So Fx into u, and kinetic energy is always half m v square. So half m v square into v. So that is nothing but mass flow rate is nothing but rho a v. So rho a v square into v. So it will becomes v cube. Now if we substitute this equation or differentiate this equation and equating with 0, we will get the condition for maximum efficiency. We will get v equal to twice of u, and if substitute this in this equation, you will get maximum efficiency as 50%. So for series of vanes, so maximum efficiency will be 50%. So it will not exceed more than that. Let us next section, that is force exerted by jet on inclined moving plate. Now we know whenever the jet is striking on the plate and which is inclined and moving with particular velocity, so in this case the lengthening of jet is occurring. Okay, so again we know mass flow rate will be rho a v minus u. Now for sake of understanding, I have considered this stationary image. This is moving, so inclined, stationary, and moving. So relative velocity will be v minus u, mass flow rate rho a v minus u. Now in this case it is assumed that the friction between this fluid and plate is 0. So whatever velocity comes in will move with same velocity, inward and outward. So force exerted by the jet in the normal direction to the plate will be given as, for normal force is nothing but is normal force, okay, acting on the plate perpendicular to the plate. So that is Fn equal to mass flow rate into initial velocity minus final velocity. So initial velocity in this case is v minus u sine theta. Okay, so for fixed plate it is v sine theta, and for a moving plate it is v minus u sine theta, as relative velocity comes in picture here. So Fn equal to finally rho a v minus u bracket square into sine theta. This equation is important. So now this Fn can be resolved in two components, that is Fx and Fy. So what is Fx is equal to Fn into cos of 90 minus theta. So Fx is nothing but Fn into cos of 90 minus theta. So from right angle triangle geometry, so this angle is 90 minus theta. So Fx equal to finally rho a v minus u square into sine theta, as sine theta into sine theta will becomes sine square theta. So now for fy equal to fn sine of 90 minus theta. So fn into sine 90 minus theta will becomes cos theta. So fy equal to rho a v minus u square sine theta into this cos theta. So now work done will be fx into distance traveled by the plate. So fx into u. So work done is rho a v minus u bracket square sine square theta into u in watt. Now next point, force exerted by the jet on hinged plate. Now let us consider a vertical plate which is hinged at point O, and jet is exerting a force at its center. So let us consider that distance as x. Now with that force exerted by the jet, plate will move with a particular angle. Okay, so its center of gravity will be moved from this point to this point. Okay, so this will be W, and normal force which we are acting along x direction, now it is along this direction. Getting? So now at the equilibrium condition, at this point all the moment of forces will becomes zero. Means whatever amount of force acting by exerted by this normal force and this weight will becomes zero. Now let us consider this triangle. Whenever the plate is moved from this to this, from, let us say I am considering from this to this point. Okay, so if this angle is theta, this is right angle triangle. Okay, this is theta, this is right angle triangle. This remaining angle is 90 minus theta by geometry. So this is 90 minus theta, so this will becomes 90 minus theta. So force exerted by the jet of water normal to the plane, that is Fn equal to rho a v square sine of theta. So in this case theta is 90 minus theta. Now next point, we need to calculate the weight of the plate. So once the jet strikes the plate, for equilibrium condition we know moment of about the point O will be zero. So there are two forces, weight in downward direction and force in upward direction. If you took these two forces will be equal to 0. So Fn into this distance and W into this distance will equal to 0. So now force moment of force Fn about hinge equal to moment of weight about hinge. So now if you take Fn into OB, so Fn into this distance OB, and second W is acting downward direction into OA. So now what is Fn? Rho a v square sine 90 minus theta into OB W. What is OA dash? OA dash is nothing but x. This is sine theta, sine theta. So now what is in sine 90 minus theta is cos theta. Okay, W into x theta. So now how to calculate this OB? OB. So for this, consider this triangle OAB, this right angle triangle. So to calculate cos of theta or OB, if you consider cos of theta equal to A by OB, cos of theta equal to adjacent side by hypotenuse, OA by OB. What we need to calculate it? OB. So OB equal to OA by cos theta, OA by cos theta. So rho a v square cos of theta OA by cos of theta equal to W x sin theta. And what we know for OA is nothing but x. Okay, so the cos theta will get cancelled. For OA, I can say it is x. Getting OA is nothing but x. So the final equation will becomes sin theta equal to rho a v square by W. Since this x will get cancelled, and sin theta equal to rho a v square by W. So this is the final equation. So this equation will provide the angle of swing when the jet strikes the vertical plate, which is fixed at particular point. Now let us understand one numerical. So a jet of water 30 mm diameter strikes a hinged square plate at its center with a velocity of 20 meter per second. The jet is deflected, or in this case the plate is deflected through an angle of 20 degree. Find the weight of the plate first, and second, if the plate is not allowed to swing, what will be the force required at the lower edge of the plate to keep the plate in vertical position. Now let us understand what they have given and what we need to calculate. So first thing they have given is diameter of jet and velocity of jet as 20 meter per second and angle, that is 20 degree, and we can easily find out the area of that jet. Diameter is given, area equal to pi by 4 into d square, so I get 0.007068 meter square. Now what we need to find out, in first case it is weight, and in second case the force which is required to maintain the plate in vertical position. So we know how to find out the weight. For sin theta we have formula, sin theta equal to rho a v square by w, sin theta equal to rho a v square by w. Now substitute this value in this equation, you will get w, or weight. So weight equal to, I can say, for if I substitute the values, sin of 20 equal to density 1000, area this one, velocity 20 into 20 by w. So w equal to, you will get the value as 26.6 Newton. Now second part, if the plate is not allowed to swing, what will be the force required to maintain that plate in vertical position? So if I am assuming this force P with at a particular distance, I am acting in opposite direction to that of force of jet, so this will be balanced and this plate will not move in any angle. Ready? So for that case, the jet is acting at the center, already it is mentioned. So jet force will be at a h by 2 and force P at the lower edge will be at distance h of that plate basically. So if I took the moment at point O, what I get, P into this distance, force P into total height of that plate is h, and force into this h by 2. So force into h by 2. So if I calculate P, F into h divided by 2 into small h, so h will get cancelled, F by 2. So force is nothing but rho a v square by 2 in this case. So I will get force required to maintain the plate in vertical position as 141.36 Newton. Thank you.